Welcome back. So this was the last slide from where we stopped, and what I was trying to explain you that using the satellite data we need to generate the landform map, which is extremely important for the user. Okay, so not only the geologist or geomorphologist will be using this information which has been put on the map here on your right hand side of the screen, but at the same time this is extremely important for the town planners, because we will put here the location or the traces of active fault in this area. Okay, so few more examples from this area. Now this is what we see close to Chandigarh when we move to Panchkula side, and this is what we call the plate boundary between the Indian plate and the Eurasian plate. So you see a very small, as compared to the Himalayas, okay, a landform which has been raised or abutting against the Indo-Gangetic plain. So the photograph is taken from the Indo-Gangetic plain side. So this plain area, what you see here is your Indo-Gangetic plain, and this is the boundary between the Indo-Gangetic plain and the Himalayas, and this raised part is of course what we call the uplifted terraces along active fault. And as I was showing in the previous slide, and in one of my lecture I talked about that there are multiple terraces which were displaced in this region, and this photograph in particular, I will go back to the slide and show you where exactly this lies. Okay, so this photograph which you see is of this area. So we were viewing the fault scarp from this side, that is from the Indo-Gangetic plain, viewing towards the Himalayas. Okay, so this is the boundary, and the landform which has been marked here is, so this is an uplifted area. So what we see is, if I take the cross section here, that is if I take the cross section on this side, then what I see is the profile will be something like this. Okay, so this is your fault scarp, and our fault in section is sitting somewhere over here. Okay, so this is typical of thrust fault. Why we are saying that this is a thrust fault, I will come to the in the next slide. So the height of this is almost like 35 to 40 meters. So this itself indicates that this is not a product of one single event. It was developed during or by different or multiple events, and this height which we see of 35 to 40 meters or more is a cumulative height which this landform has acquired over the time. Now again, as we discussed in one of the lecture, that we should avoid putting structures right on the top of the fault scarp or on the hanging wall side. So if you see the location of one of the major building, I'll mark that, is sitting exactly on the top of the fault scarp, and this building belongs to the army headquarters. For me, this is not the good location. The building you can see here, which I have marked with the arrow, which is not exactly the good location to be put on, because this is an hanging wall which will move during an earthquake and will have comparatively higher ground acceleration compared to what we see on the or observe in the Indo-Gangetic plain, that is your footwall side. Okay. So there are two scarps which we identified here, and these two scarps again indicate that there were more events or the younger events which are reflected in form of the smaller scarp here. So this is another way of presentation where we have used SRTM data, and Landsat data is draped on the SRTM data, and we prepared the 3D perspective view of the region. Okay. So now if you take into consideration the well planned city sitting very close to an active fault which has a capability of triggering earthquake of magnitude greater than 7.5 and less than 8. Okay. So it is not very far from that. Okay. Further close up of that active fault trace which runs over here, I would like to show you few civil structures which are sitting exactly on the fault. Okay. And that was done unknowingly because they were not aware of that the active fault is passing through this area, and since we are looking at the youngest contact between the Indian plate and the Eurasian plate, the active fault which we call as an Himalayan frontal thrust is the most active amongst the other thrust system exist in Himalaya. This is going to move in near future. Okay. So if you look at this part, we have been able to pick up the active fault scarp in the cantonment area. So this fault passes through the cantonment area, and this is the view, a very small scarp which you can see here. Even you can make out with the help of the person standing here. So this is around 1.1 meter or 1.5 meter high. Okay. Further, when we moved into the along the scarp, okay, and we tried to map, we found that this fault scarp, there are few smaller buildings are sitting on the footwall side, but again there is a water tank over here which is sitting on the hanging wall side, because this side is your hanging wall and this is your footwall side. Okay. So this I am talking trying to explain you that after doing the photo interpretation, this is what is required. Okay. So the terrain evaluation can be done in a complete sense after you do the proper photo interpretation and do the field work and mark your fault trace very precisely, the part of the tracing the structural features. Okay. And this is a close up here which shows the fault trace in section. Okay, that is the fault plane. Further, we were able to trace the same feature within the cantonment which was been marked, and again this area is now used for the race course. Okay, the horse riding, they have redeformed, or we can say that they have completely modified this area for the race course. Now this was a quite worrisome part. So last say 10 years, okay, a lot of construction has come up in this area, and I would say that of course the requirements in terms of the building codes and all that to provide an earthquake resistant building is taken into consideration, but if not, then is a very alarming situation that these buildings will definitely be affected by the earthquake if it is triggered along HFT or the active fault which is very close to the Chandigarh area, and this is not very far, hardly it is about 2 kilometers from the active fault. Okay. and if you consider the severity of the earthquake energy which has been released during an earthquake of 7.5, then it can affect the area covering more than 250 kilometers and less than around 300 kilometers. So this is the photograph which I was showing. That the previous one was the close-up, but this photograph I have taken from the fault scarp. So this is the fault scarp here, and you can see that hardly the distance is around 2 kilometers, even less than 2 kilometers at some points. Okay, so it is not very far, and this region will experience high ground acceleration, okay, because it is sitting close to the fault. And usually in the seismic hazard assessment, we also consider that how far the site is located from the fault. Okay. Another photograph of the fault scarp passing through the cantonment. This is the front gate of the cantonment area, Western Command, and you can make out this is where we are standing is the bike. The person who's here on the bike is the Indo-Gangetic plain, and slightly elevated portion which you can see here is your uplifted region. Okay, and the fault passes through this one. So this building which you can see here, okay, the white building is the officer mess, where they have parties and all that, but this building is exactly sitting on the fault scarp. Okay, so this will definitely break. So now you can recall the example which I was talking about of 1995 Kobe earthquake, and the building or the house, it just was marginally close to the fault where the compound wall got displaced. So what will happen to this structure if there is a displacement on this fault? Okay, another one, this is in Suraj Talkage, which is, or Suraj Cinema Hall, which is also close by to that area. The fault trace exactly passed through this region, or that is what we call underneath this. Okay, or I would say that it is somewhere over here. Okay, it goes like that. So this is again an building which is should not have been constructed on the fault trace. Okay, so these are few examples which worries us that the mistakes have been done in the past, and that was because of the unawareness. Okay, and people were not knowing that where exactly the active fault passes through. So what we do in further is that after identification of such landforms and the features, using high resolution satellite photographs or high resolution data, and even you can now use UAVs to map such features on much higher resolution and identify the location, because this is another important exercise which we do to know what is the past history of the earthquake on that particular fault. Okay, so we open up sections. I am not going to go into the detail of this, but this is a section which we see, and this younger scarp. Okay, so we opened up the section. This section which I am showing here is from this location. So we opened up a trench and dug the trench here to see the past signature of past earthquakes, okay, or ancient earthquakes in this region. And then what we found was that this fault was responsible for triggering a large magnitude earthquake in 1500 AD. So this is our finding. So this is what we do, but I am not going to get into the detail. Maybe you can ask our TA to pass on, if you require or if you are interested, the publication on this part. Okay, now coming to the further few kilometers north, if you move, we had another fault, Mughal Garden fault. So in this lecture from the Indian side, I was talking about one is Taksal fault, which was strike slip, Himalayan frontal thrust fault. Another fault which we identified in that domain is Pinjore Garden fault. So Pinjore Garden fault, the previous fault which we were discussing was here. The Pinjore Garden fault is running here. Okay. Again, this fault was picked up for 45 kilometers along the strike, and the features which we identified again was bothering us. Okay. The features as well as the structures which were being constructed. Okay. So I'll give you like very good. So the recent construction which we did was a mistake because we were not aware, but the historical construction, the ancient archaeological sites or maybe the Indian structures which were constructed in 17th or 16th centuries, they also did not realize about the fault trace. Okay. So if you take this portion, it has been shown, this portion of the figure has been shown here of the corona photograph, and what we have is, these are the locations. So we have a Mughal Garden here which is very famous, and most of there is a lot of tourists which they visit this whenever they visit Chandigarh, other than the Pinjore Valley, and we have like traces which are marked by these arrows. Okay. So fault runs here, one, another smaller fault, and third over here, and fourth, this is a Taksal fault. Okay, which I was talking. And if you go further this side, then you will come across the Chandigarh fault or Himalayan frontal thrust. So as I have shown that we have 1, 2, 3 major and 4 major faults along with the smaller faults in between. Okay. So let's see what we fixed up. Again, we did the similar studies. We did trenching. We opened up the section to see the past earthquake, but I will not go into the detail of that. So this is how it looks from the space. This is a Google Earth image, okay, where you can see a very well structured garden. Okay, and this portion here, usually this is typical of Mughal architecture, where you will find that in between, in the center of the any such garden, you will have a stream or the water pathway which will flow through and through. Okay, so they will the Mughals were very much keen or fascinated with this type of structure. So even if you go in Kashmir or in Delhi, you will find that these Mughal gardens are of typical, a very similar pattern. Okay, so what they need is that they need a big gradient from somewhere over here, and they try to flow through the water. Okay, so that they have the beautiful canal, small canal or the waterway in the center of the garden. Okay, so they used the elevated part which existed naturally during that time, without knowing that this is a fault scarp. Okay, so what they did was, let's see further here. So this is again which we see from the corona satellite photo, and the fault passes through this part here. Okay, exactly. So there is a beautiful fault scarp which exists here. Okay, so we have, of course, this is an old structure here. At the same time, we also have few constructions which have been done here. They are also exactly sitting on the fault scarp. Okay, so you have a combination of the ancient structure and the new structures or the recent structures which people have made or constructed, exactly doing the same mistake. Okay, but again we can say that this was because of unawareness. Okay, but let's see what we identified in the field. This is a very beautiful hotel which is now, so it was a part of the Mughal garden, but now it has been taken over by a sort of an heritage hotel here, which is exactly sitting on the fault scarp. So very low fault scarp you can see here, and this fault runs through this area over here. Okay, this is one. Second is, you can see that this whole main step, okay, what they call as a big step, and this is exactly over here actually. So I have taken the photograph looking from this side. Okay, so this is one point. This is outside so this is like, if I say this is on the left hand side, which we see these two photographs here, and on the right hand side what we found was a very beautiful scarp. Okay, so this is a wall, and this wall is here, this is the wall of the garden here, and then we have taken the photograph looking at here. Okay, so there is a typical fault scarp which runs over here. Okay, now fortunately this fault did not move after the construction of the Mughal Garden. Okay, so indirectly we are able to obtain a date that since the construction of this Mughal Garden there was no movement on this fault, and this increases the likelihood of having the earthquake in near future. Okay, this is again the same area of the photograph, but this photograph was taken almost 15 to 20 years back. Okay, and this photograph was taken in 2001. Okay, again almost like more than 10 years back. Okay, now people have a tendency to pass through because there is a pathway which has been constructed here by the local administration, but they don't know about that this is the feature which is going to trigger an earthquake in near future. Okay, so this Mughal Garden details, if you take, it was constructed in 17th century, and after that there is no earthquake because there is no damage to this particular structure. Okay, so this is a big step here which you can see, and they have used this big step which is a fault scarp for providing gradient to the water pathway in the center. Okay, similar feature you will also see in Taj Mahal, in Humayun tomb, or the garden in Sundar Nursery in Delhi. Okay, so typical features or the architect you will see in most of the Mughal gardens. So this was done by mistake. They were not aware of that this is a fault scarp. The elevation which they see, which was naturally occurring elevation, is a fault scarp. Okay, so whenever there is a next earthquake coming on, this fault will completely destroy the structure. Okay, so these were the details which we gathered from this fault. Okay, so I'll just move ahead and come and stop wherever it is more important. Okay, so this is the same area which I have shown in the past, okay, in the couple of slides. Yeah, coming to this is what we did. Okay, now this is important. There was no other way of crossing this rail track. Okay, and this rail track is one of the major rail track which takes you to Kalka, and from further there you will take the smaller or the meter gauge rail for Shimla. Okay, now if you look at what we have been discussing about the fault scarp, then you will be easily able to make out that there is a fault trace over here, and the elevated portion which you see here is the fault scarp. So this rail track, okay, is exactly crossing the fault scarp, and this again I am pretty sure that this was done without having any awareness, or they were not knowing about this fault scarp. Okay, and they have constructed the rail track on the top across it. Okay, so the question is whether we can avoid. The answer is may not be. We will not be able to avoid this, but then what measures we have taken to protect this rail track? Okay, that question remains always. Okay, so again similar type of studies we did. We opened up the trench, and then we found that this fault triggered earthquake one in around 4,000 years before present, and one is 10,000 years before present. Now another mistake, but this is a very interesting area. Okay, this is on the left bank of Beas River. Okay, so I'll continue this part in the next class. Okay, where we will show you that how the hydel power stations are sitting right on the top of the active fault scarp, and that is again has been done because of the unawareness. Okay, thank you so much.